Synthetic division is a really helpful topic when it applies, when you can actually use it instead of using the full polynomial long division process. But maybe there's been times where you get to the end of a problem and you think something looks wrong because of a remainder. Well, in this video I want to show you an example of applying synthetic division and getting to a remainder at your answer, and how you can actually write that and explain that as the answer to your problem. So if that sounds good to you, be sure to stick around to the end of the video. And without further ado, let's go ahead and jump into the example and I'll show you what I'm talking about. Use synthetic division to divide negative 3x to the fourth all over x plus 2. So again, whatever's on your denominator, you need to make sure that it's just x plus or minus some number. If so, you can use synthetic division, assuming you have a polynomial on your numerator. That obviously has to be the case also, because synthetic division is a form of polynomial long division. So you definitely need a polynomial, and then you need a linear term that just has an x coefficient of 1. So it's just going to be x plus or minus some number. Keep in mind, we need it to be x minus k. So the sign is going to be opposite. So x plus 2 tells us our k is actually negative 2, because x minus negative 2 is x plus 2. So then what we're going to do is confirm if our numerator is already in the right order, where we have our highest powered x term first, going down to our lowest powered x term, and then our constant number being added or subtracted at the very end. In this case, we only have one x term. So how do we deal with that? Well, what you can do is think of negative 3x to the fourth is basically the same as negative or plus 0x cubed plus 0x squared plus 0x plus 0. So if you ever are, missing any powers of x in the middle of your polynomial or towards the end of your polynomial, you kind of need to fill in the gaps with zeros. So make sure that when you write your kind of synthetic division bracket here, make sure that whatever your highest power x is going to the farthest left. And then make sure you have enough zeros or enough terms in general to get you down to your constant number being added or subtracted at the end. So in this case, that's a bunch of zeros, but you do need to have those because they hold the correct place, so that we can actually figure out what those other terms would be. So doing this, we would have a 0, a 0, a 0, a 0. So we need 4 extra zeros to get from x to the fourth down to our constant number all by itself. If it helps you to write all this out like this, I would definitely recommend doing it. But kind of a shortcut there too even is whatever your highest power x term is, so in this case x to the fourth, you need one more total term than that. So we have 5 total terms here based on the fact that we have our highest power x as x to the fourth. Okay, so once we've done that, we can write our k over here. So k is negative 2. That's not the best looking 2. There we go. So a little better. And then we can start by going through the synthetic division process. So we're going to always start by just carrying, whoops. Uh-oh. Okay, sorry about that. So we're always going to just start by carrying our first term down. So negative 3 is going to be written right here. Okay, then we go diagonal. Diagonal is always going to be multiplication. So we're going to go negative 3 times negative 2. Gives us positive 6. And then we're going to go down. Going down is always addition. So 0 plus 6 is 6. So this is, again, you're just going through the same steps. You're basically just zigzagging down, diagonal, down, diagonal, down, diagonal, down, diagonal, until you get to the very end and have the same number of terms down here that you had up here. That's really all you're doing. Whenever you go down, you're adding. Whenever you go diagonal, you're multiplying. So now we have a 6 times a negative 2 to do our next diagonal move. Gives us negative 12. Now we're going down. So we add 0 plus negative 12 is negative 12. Now we're going diagonal. So we multiply. Negative 12 times negative 2 gives us positive 24. And now we're going down. Whenever you go down, you add. So 0 plus 24 gives us 24. And now we go diagonal. Diagonal is multiply. So 24 times negative 2 gives us negative 48. And now we go down, so we add. So we go 0 plus negative 48 gives us negative 48. Okay, and now we have 5 terms down here at the bottom. We had 5 terms up here to start. So now we know we're done doing the down diagonal thing. We've gotten to the end of that. But now what we need to do is think about how to translate this into a polynomial. So to do that, there's really just one thing you need to think about. But if you are getting value out of this video so far, do me a favor, smash that like button down below, hit that subscribe button and that bell icon too while you're down there so you can be notified when I come out with all my new videos. We can keep crushing it all term long in calculus, pre-calculus, whatever math you're taking. We'll keep going through problems like this together throughout the term. So hit that subscribe button. Now to finish this off, we'll kind of wrap it all together here. Start with whatever your highest power x term was at the beginning, so x to the 4th, and then take 1 away from that. So we're going to have an x to the 3rd to start down here. Now you're just going to put this as your coefficient, your first term down here as your coefficient of this highest power x term down here. Then you're going to do this coefficient times the next power x term down, so x squared plus 6x squared. Then this number times the next x power down, so minus 12x. And then this second to last number is always going to be your constant coefficient term. I keep calling it a constant coefficient term, just your constant term. Sorry about that. So 24 plus 24. And then this final number here is always going to be your remainder. So basically we have a remainder of negative 48. But that's not really the best way to write this. What we probably want to do instead is write it as minus 48 over whatever this was, the denominator of your fraction originally. So minus over x plus 2. Another way we could write this, just to, if it helps make it a little bit easier for you to follow, negative 48 is our remainder. So we'll just put negative 48 as our numerator and then just say plus. So now this is the result of dividing negative 3x to the 4th by x plus 2. You end up with all this. Well, I hope you found this video helpful. If you did, we probably want to keep it rolling, keep practicing some synthetic division problems. Just go click that video right there. We'll go through another example so you can get another practice problem in, which by the way, is always going to be the best way to learn a new topic. So go click that video. Let's keep it rolling.